Hello, my dear students. Once again, welcome back for the continuation of chapter 7 in chemistry, that is metallurgy. As you know that we were doing extraction of aluminium. Let's revise what we have done in previous class. You know bauxite. Bauxite is the cheap ore of aluminium and its chemical formula is Al2O3 2H2O. Next, concentration of the ore. What is concentration of the ore? Concentration of the ore is the removal of impurities from the ore. Now, bauxite can be concentrated or purified by Bio's process, and this process involves three main steps. In the first step, bauxite is treated with hot concentrated sodium hydroxide solution. And this bauxite gets dissolved in hot concentrated sodium hydroxide solution and it gives sodium aluminate. Whereas impurities like ferric oxide and silicon dioxide do not dissolve in bauxite, which are called red mud. In the second step, the solution is filtered and cooled, and then it is diluted with water at 50 to 60 degrees Celsius, where it undergoes hydrolysis and gives aluminum hydroxide AlOH oxide 3 in the form of precipitate. The rate of this precipitate can be increased by adding a small crystal of aluminum hydroxide, which is known as seeding. Now, aluminum hydroxide, which is obtained in the second step, this aluminum hydroxide is washed and then dried in the third step, and then it is heated nearly about 1300 degrees Celsius. When it is heated, it decomposes into alumina and water molecule. Alumina means aluminum oxide, which is a very stable compound. Now we have got aluminum oxide. Now next step is reduction of this aluminum oxide or alumina. Here this alumina cannot be reduced to aluminium by using common reducing agent like carbon monoxide and hydrogen, because aluminium has great affinity for oxygen. This aluminium can be reduced to aluminium only by the method of electrolysis. Even the electrolytic reduction of this alumina is also very difficult. Let's move on to the electrolytic reduction of alumina by Hall-Heroult process. Electrolytic cell. Electrolytic cell means is a vessel or the container where electrolysis is carried on. This electrolytic cell is made of iron and lined with carbon. Now next, electrolyte. You know electrolyte. Electrolyte is a chemical compound which conducts electricity when it is in aqueous solution or molten state. Here electrolyte is a mixture of fused alumina, cryolite and fluorospore in the ratio of 1:3:1. One part of fused alumina, 3 parts of cryolite and 1 part of fluorospore. Here, this mixture of fused alumina, cryolite and fluorospore acts as an electrolyte. Here, mixture of fused alumina, fluorospore and cryolite acts as an electrolyte. Now next, anode. Anode is made up of graphite rod. These are anode. This anode is the electrode which is connected to the positive terminal of the battery. Here, cathode is the electrode which is connected to the negative terminal of the battery. Cathode is made up of carbon lining of electrolytic cell here. Carbon lining of this electrolytic cell acts as the cathode. Cathode is the electrode which is connected to the negative terminal of the battery. Here this carbon lining of the electrolytic cell acts as the cathode. Now this mixture of fused alumina, cryolite and fluorospore or powder coke is sprinkled over this mixture because this coke prevents the bonding of this graphite anode and also heat loss by the radiation. Here the electrolyte is covered with coke powder, or you can say coke powder is sprinkled over this electrolyte or the mixture of fused alumina, fluorospore and cryolite. Now ionization reaction. Here cryolite, sodium aluminum fluoride, it ionizes or dissociates into sodium ions, aluminum ions and fluoride ions. Sodium, its valency is 1, 3 atoms of sodium. Aluminum, its valency is 3. Fluoride, its valency is 1. There are 6 atoms, so 6. Calcium fluoride ionizes or dissociates into calcium ions and fluoride ions. Calcium valency 2. Fluoride valency 1. There are 2 atoms, so 2F negative. Alumina dissociate or ionize into aluminum ions, and oxide ion, aluminum valency 3, 2 atoms, oxide valency 2, 3 atoms. Now what happened when electric current enters into this electrolytic cell? There are 3 positive ions: sodium ion, aluminum ion, calcium ions. All of them, they migrate towards the cathode, Here cathode is this one. Here sodium ions, aluminum ions, calcium ions, all these are the positive ions or cations. All of them, they migrate towards the cathode. Here cathode is here, lining of this electrolytic cell. Only one of them they discharge at the cathode, that is aluminum ions. This aluminum ions, because the position of aluminum is lower than the position of sodium ions and calcium ions. So the reaction at cathode, aluminum valency 3. So 2 aluminum ions gain 3 electrons. 2 3s are 6 electrons. Here aluminum gets reduced or become discharged at the cathode by the gain of electrons and form a neutral aluminum atom. And reaction at anode. Here one step is missing. I'll just write here oxygen, this is anode. Then negative ions, there are 2 negative ions, fluoride ions and oxide ion. Both of them migrate towards the anode, From here they migrate towards the anode. Only one of them they discharge at the anode, oxide ions. So here 3 oxide ions, 3 2s are 6, loses 6 electrons and form 3 molecules of oxygen. Oxygen gas is evolved at the anode, and this oxygen oxidize this graphite anode to form carbon dioxide. So oxygen which is evolved at the graphite anode, this oxygen oxidize this graphite anode to carbon dioxide. So here in this process, graphite has to be replaced from time to time because oxygen which is evolved at the anode, this oxygen oxidizes this graphite anode to carbon dioxide. Dear children, here we have come to the end of today's online class. Thank you very much.